Hello, everybody. My name is Xiaoyu Zhang. I am a fifth-year PhD candidate from the University of California, Davis. Today, I will present our work, ConceptEVA, concept-based interactive exploration and customization of document summaries. So recently, there is a upsurge of large language model like ChatGPT. So out of curiosity, I threw our paper into ChatGPT and asked it to summarize the content of our paper for me. So ChatGPT provide me with a decent paragraph of a summary for our paper. But when I look at this paragraph, I was wondering, can I trust this summary? How can I evaluate its quality and the relevance to my focus of interest? And finally, can I get a personalized or customized summary with this ChatGPT version as a starting point? The answer is yes. And that leads to our vision for this paper, which is to use visualization to make AI better tools to assist human in a safe, trustworthy, and personalized environment. In particular, we combine large language model and exploratory visual analytics to help human readers to read and understand scientific documents and create customized summaries. We leverage interactive visualizations as a bridge for human AI collaboration and allowing human readers to effectively communicate with the AI agent to evaluate and customize the summaries. So in order to achieve this high-level idea, we developed a workflow with three main stages, and I will dive into a bit more details for each of them. First of all, the original input of our workflow is the scientific document we want to analysis. By querying a domain-specific ontology, we extract all of the concepts of our interest from the document and convert it to a higher dimensional word embedding, and then further project the word embeddings to 2D space. Along with the context information of these concepts in the original document, we input them to our visualization interface to produce a interactive visualization where the users can interact with each of the concept represented as a circle in this visualization. The users can also select the concepts they are interested and want to include into the summary and input them into the next stage of our workflow. So in the next stage, we will retrieve the related sentences from the document, and together with a base summary automatically generated by our language model, we will provide the users with a machine-generated summary. We were aware that such version of the summary is not perfect, so we also develop a summary editor for the users to interactively paraphrase, delete, or insert content in the machine-generated summary. Finally, we will produce a version of the human-in-the-loop summary, which can be further improved in a new iteration. And in this workflow, the summary customization process can be iterative by inputting the human-in-the-loop summary as the base summary in our workflow. And in order to convert this workflow into a visual analytics system, we conducted a preliminary study with 8 higher educational professionals to understand how they motivate, guide, and evaluate their students' paper summaries. And based on their insight about the process, content, and requirements of a good summary, we derive 4 design requirements and develop our system based on these requirements. So our users can interact with the concepts in the system and check how they are addressed in the original document and in the summary. They can also explore the paper information panel on the left to check the context of the concepts and use our focus on function to focus on the concepts they are interested in. And when it moves to the summary customization stage, we support the users to interactively select the concepts they're interested in and feed them into our AI agent to customize a better version of the summary. And after that, the users can further edit the summary in our summary editor until they are satisfied with the abstract. We evaluate our approach through a expert review and a within subject study. And from the study, we found that the users' participants' satisfaction level with our human-in-the-loop summarization is much higher than the pure automated summarization from the AI model. And at the same time, we found that the human-in-the-loop summarization generated with ConceptEVA can reach compatible user satisfaction level compared to their manually generated summary. And a separated analysis on the 2 test papers of our user study confirmed with this observation. At the same time, we measure the user's summarization experience with a NASA TLX scale. And we found that although the satisfaction level was similar, the users will spend much less time and effort when they use our tool, ConceptEVA, to customize the summary of the paper. And we also observed that there are several factors that can influence the user's summarization experience, and we encourage our fellow researchers to incorporate these big factors into their further research and develop process. So a quick wrap up, in ConceptEVA, we developed a mixed initiative approach that integrates interactive visual analytics, knowledge graph, and NLP techniques for evaluating and customization long document summaries. So according to our study, we found that our tool can achieve compatible user satisfaction level with the manual generated summary, but with much less time and efforts. So with the recent upsurge of large language model like ChatGPT, we believe that our tool provides a intuitive human-in-the-loop solution to help build a more safe and reliable interactive experience with such large language model. Finally, I want to shout a big thank you to all my co-authors and the people who help with this paper, and also the experts, participants, reviewers, and sponsors who contributed to the final form of this paper. That concludes my presentation today. Thank you for your attention.